This question is from section 11.3. Number 1, it's looking at doing a hypothesis test and finding a confidence interval comparing two independent samples, the population means for those. So not paired. Here we go. We're not given a scenario for this problem. We're just given some summary statistics about the two populations, specifically the sample mean and the sample standard deviation for each one. We're told they're normally distributed, which they need to be since the n for each of them is less than 30. And so we'll go ahead and the problem asks for the p-value to do our determination to see if we can reject the null hypothesis, and then a confidence interval constructed. So we're going to do that in StatCrunch. So for these problems, we're going to do a t-test, and these are not paired. It's two samples with data. So the sample mean for the first one is the x bar, and the s, and the n. And then sample mean for the second one, x bar, standard deviation, the s, and the sample size is the n. We're going to do a hypothesis test, and we're going to try and figure out if the difference is not equal to 0. And we'll go ahead and show the critical value, even though it's not necessary. Okay, compute. So here we are. Here is all of the information that we need for this problem. This specific problem asks for the p-value, which is 0.355. So you can see that is in that part. So since 0.355 is much greater than the 0.05 level of significance, we would not reject the null hypothesis. It says this is not unusual. The difference is in these. Okay, now we're going to construct a 95% confidence interval, so we can go back to that same problem and just, instead of a hypothesis test, do a 95% confidence interval, and again, compute. So here, this is our lower limit for the confidence interval and our upper limit for the confidence interval. Okay, I hope this helps.